Hey class, let's talk about sediments. This aerial image of the Betsiboka River in Madagascar is an excellent example of a depositional environment. So what you see here is a river, and the river is discharging into the ocean. And so what happens here is you have a fast moving body of water, so a river, flowing into a still body of water, a relatively still body of water, the ocean. And so what is going to happen here? You see all that orange suspended clay and silt? Well, that's suspended in the moving river water. But then what happens when it hits the relatively still ocean is those particles are going to be able to settle out and deposit themselves onto the ocean floor. And what you're seeing here is an example of a delta. So a delta is a depositional environment. And throughout, we're going to start in this little clip right here talking about mechanical weathering, and in the next clip we'll get into chemical weathering, and then from there we're going to combine weathering, erosion, transportation, and deposition so that you can just see them in little digestible clips. Go forward. So there are different types of sediments. Here you see clastic or detrital sediments. So these are loose fragments of rocks or minerals that are broken off of bedrock. So they just were physically broken apart. Then we have chemical sediments. So these are mineral crystals that precipitate directly out of water. And if you need a refresher on precipitate reactions in chemistry, I posted a crash course video for that very reason. And precipitate is simply when a solid falls out of a solution. That is precipitation. And biochemical sediments are formed from parts of organisms. So for example, shells or broken up shell fragments. So we can get a biochemical sediment from shells, and if you break that up, we can get a clastic biochemical sediment. So you see how we can combine these together. Then weathering. Weathering can be really easy to get confused with erosion, but weathering and erosion help each other out. They are different processes. So how it works is weathering is the physical and chemical breakdown of pre-existing rock. So weathering causes rock to break down. Erosion requires a fluid medium to actually lift the broken up pieces, the weathered rock material, away. And the fluid medium can be water, ice, or air usually. Now, physical weathering is also known as mechanical weathering, and what it does is it breaks intact rock into clasts, and clasts are just unconnected grains or chunks. And a rock, by definition, is just interconnected minerals, and if you have sedimentary rocks, it would be minerals that are cemented together. And clasts are often referred to as detritus. Different examples of physical weathering include jointing, frost wedging, thermal expansion, so freeze-thaw action, salt wedging, root wedging, and even animal attack. So as I move through these next few slides, I'll be giving you examples of each one of these physical weathering methods. Let's begin with jointing. Jointing starts with a natural crack in the rock. And so we have these natural cracks in the rocks that are weak spots. And exfoliation joint splits bedrock into onion-like sheets. So just think about as you're peeling layers off an onion, they're peeling away at these weak spots. So those would be joints. And whenever you see a pile of blocks at the base of a slope, that is an example of talus. Let's look at frost wedging. So with frost wedging, you're actually getting water is accumulating in these joints and freezing. And when you make an ice cube, water expands when it freezes. So you have water getting into these joints or cracks, and it's expanding, and through the expansion, it is breaking the rock apart. In the Bill Nye video I have posted, he refers to this as erosion. It's tricky because it is happening in water, but the actual expansion of the solidifying water, so the turning of liquid water into ice, is physical weathering. Next, we have salt wedging, which is very similar to our frost wedging. So we get salt crystal growth inside cracks, and that also breaks the cracks open, pushes them further apart. Then we have root wedging. So here we have a plant or a tree that physically grows through a weak spot or joint in the rock and pushes it further apart. That is root wedging. And then we get thermal expansion. So this happens in areas where you get pretty big diurnal temperature shifts. Diurnal is just throughout the course of a day. And so like in the desert, it gets really warm during the day, and then it cools down drastically at nighttime. So what happens then is the rock surface heats up during the day and it expands, and then it cools at night and contracts, and this expanding, contracting starts to loosen up the outer layers of the rock, and so it breaks apart. Here's another example of thermal expansion. So on older railroad tracks, you can see that as well. So you see that this metal, which is a great conductor of heat, started to warm and expand, and now it is not completely in line anymore. Another form of physical weathering can actually be animals burrowing into rock. So this is an example of a pitot clam burrowing into rock. It's an example of physical weathering. Okay, that's my last one. Up next, we'll be talking about chemical weathering and then how they work together.